My name is Andrew Neal. This is Homework 6, Part 1, controlling an AOU with an FSM in a top-level design. As we look at the code, I have created the AOU. The AOU has two 4-bit inputs. It also has 4 operations, AND, OR, NAND, and XOR operations. This operation is selected by a select op line, which is a 2-bit input. And then it has an output of those 2 inputs as a 4-bit output. As we begin the architecture, I process monitor A, B, and the select op line. As we step into the case statements, as you see, when select is 0, 0, or when op is 0, 0, the operation is AND. When the operation is 0, 1, it's OR. When 1, 0, NAND. When others, XOR. As we look at the FSM, FSM has a reset and a clock input, and it has a 2-bit output. In the architecture, I created these 4 states to represent each of the operations. My 2 signals are current state and next state. These 2 signals will determine which state it should execute. I begin the process of the reset and the clock. If the reset is equal to 1, current state equals state 0, which means everything is reset back to 0, 0, 0, 0. And if clock event and clock equals 1, this means that it is on a rising edge triggered clock, meaning that when the clock goes to 1, current state is next state. As the process current state, when state 0, next state equals state 1. This is just going through the states sequentially. The output is at 0, 0. When state 1, next state equals state 2, output 0, 1. When state 2, next state equals state 3, 1, 0. When state 3, next state equals state 0, 1, 1. As we look at the top level, tying them together, I've created 2 4-bit inputs to represent the 2 inputs of the AOU. I have the reset and the clock as the inputs and a 4-bit output. My architecture, I have a FSM temp signal, a 2-bit signal, which will be displaying the operation select line, which determines which operation is executed. Here I create my component AOU, which is just restating the inputs and the outputs of the AOU. I create the FSM component. Reset clock has output, same as the FSM entity. Right here is where I am mapping the FSM and the AOU to the outputs in the top level design. As I step over here to the simulation, you can see that my 2 inputs are 0001 and 0010. As I step through it, I leave reset as 0 for now. Clock is 0 just to show that it starts at state 0 and changes when the clock hits 1, rising edge trigger, meaning it goes to the next state. And this operation, whichever one in the AOU is performed, let's go up here. That would be the OR operation. This would be the AND operation. This one would be the NAND operation. This one would be the XOR operation. As you can see, they all change on the rising edge trigger when the clock equals 1. And just to show that I stepped through all states and it restarted back to 0, I set the reset to 1 to show that when reset is 1, everything goes back to 0. As we get down here, reset goes back to 0. When the clock hits 1, the clock, let's see if I can find it. Next state equals state 0. Oh, I'm sorry. Current state equals next state. So it goes back to the current state before the reset hit 1.